Welcome, everyone. We're going to be looking at lesson 1.02 today, looking at angles and their measurements in degrees and radians. But before we get into that, take a second to try the warm-up. So use the given triangle to find x. So the first thing I notice is that this is a right triangle, and I'm trying to find one of the sides. So our first thought might be that a squared plus b squared equals c squared. But unfortunately, if we're going to do that, we need to know two of the sides, and I only know one. But I am given an angle. So if you have a right triangle and you have one of the other angles, that means you can use sine, cosine, tangent, one of our trig functions. So I have to decide which one to use. What I use is based on the angle I am given. So I have one side that would be across or opposite, and one side that is touching it or adjacent. The other side, the one that is always across from the right angle, is always the same thing. That is my hypotenuse. So I have my A and I have my H, which means I have cosine, because cosine is adjacent over hypotenuse. Right? If I had been given the sign across, then I would have been using sine. If I had been using O and A, that'd be tangents. So now I'm just going to fill in the pieces that I know. So I know the angle measurement is 35. The adjacent side is 12. And the hypotenuse is that x. So I need to isolate x, plop it in my calculator. All the work is done for me. Here's where I have to be careful. The x is in the denominator. So I'm not going to divide by 12. I'm going to get that x out of the denominator by multiplying. So this gives me x times cosine of 35 equals 12. So now I can divide by cosine of 35. And that will give me x equals 12 over the cosine of 35. Plop that in my calculator, see what it spits out, and I'm good to go. So let's take a second to look at that in the calculator. So I'm in my calculator, and now after today, this is going to be very important since we're talking about radians. Make sure when you are using your calculator, you're in the right measurement. So if I hit my little kind of settings graph bar, I see our two options here. We see radians and we see degrees. Of course, it's being slow and not, there it goes, radians and degrees. So we want to make sure for this problem, we are in degrees. If this was in a radian measurement, as we're talking about today, then I would need to switch it. So always double check your unit of measurement. So I'm in degrees. So I can now go over here. So I have 12 divided by, I can type cosine, or if I go into my functions, I see my main three right at the top here. So I could also just hit cosine 35, and it spits out 14.649, which would round to 14.65. And I'm basing the rounding off of my answer choices, which each had 2 decimal places. So I can go back, and I see that this was answer choice D. All done. So let's get into our new lesson. So again, this is lesson 1.02, and we're looking at angles and radians. So to start off with, a few definitions, which are super important to make sure we're kind of on the same page, especially when I use certain words, that you know what I am talking about. So the first word is an angle. So you might think, well, I know what an angle is, but we want to make sure we have the correct definition. So an angle is formed by rotating a ray around an endpoint or vertex. Okay, so you start and then you're going to be doing some sort of rotation, and the point where the rotation is occurring, that is that endpoint or vertex. Okay, so if we remember, a ray has an endpoint, stopping point at one side, an arrow at the other that keeps going. So these aren't lines that go in both directions, they are rays. They have that endpoint or a stopping point. Okay. So you can draw any sort of angle by rotation, but what we're going to be doing a lot of is working on our coordinate plane. So an angle on the coordinate plane is in standard position if the vertex is the origin and the initial side is on the positive x-axis. So what that means is every time you draw an angle, you are always starting in kind of that first positive side of the x-axis. So that is your initial side. That is what you start from. You will then go from that and rotate either up or down to make a second side, which is the terminal side or where you end. Okay, so you start on the x-axis, you then go from that x-axis and you start rotating, and wherever you stop, the space between them creates that angle. So the initial side is where you start, the ending side is where you stop, the space between them is the angle. Okay. What is very important, especially on the coordinate plane, is that rotation makes two types of angles. When you rotate up, or in this case, forward, this is going to create a positive angle. Okay, so anytime you are moving counterclockwise around the coordinate plane, that creates a positive angle. When you go backwards or clockwise, but down and around, that will create a negative angle. Okay. So this one might give me positive 30 degrees versus the angle over here on the right would give me negative 30 degrees. So that negative tells me which way I am rotating, which way that rotation goes around the coordinate plane. So keeping that in mind, let's just see how well we understand our coordinate plane and that initial rotation of angles. So as a reminder, we have our quadrants. Each quadrant is 90 degrees. Identify the quadrant where each angle would fall. So we've got 70 degrees, 300 degrees, and negative 135 degrees. Which quadrant would each of these angles fall? So what is important is to remember that each of these angles has to start in that standard position. There's my initial side right there. From here, I'm either going to rotate up or down the degree amount. So 70 is positive, which means I'm going to rotate forward or up. 70 is less than 90, so I might go close to 90, but then I would stop and I would finish in quadrant 1 because it is between 0 and 90 degrees. Okay, so let's switch colors. Okay, so let's try now 300. So I'm going to start the same side. 300 is positive, which means I'm going to rotate up or forward. So I'm going to go to 90. I'm going to go to 180. I'm going to go to 270. And then I'm going to go a little bit more. If I went all the way and made a full circle, what would the degree measurement be? 360. Full circle, we got to remember, is at 360 degrees. 300 is between 270 and 360. So I would finish here. So this huge, big, almost first circle is 300 degrees, but that would finish in quadrant 4. So last but not least, which can be some of our trickiest ones, is we have a negative angle. The only difference is we go backwards, but then you have to remember to change those degrees. So I'm going to write on the negative amounts. So if I start at 0 and I went backwards 1 quadrant, I would now be at negative 90 degrees. Each quadrant is still 90, just in the negative direction. So another 90 would give me negative 180, negative 270, and then negative 360. So that each axis has a positive and a negative equivalent. So I'm now going to go backwards to 90 and then a little bit more, since 135 would be between 90 and 180. My angle would be here in red, or in, there we go, quadrant 3. Hopefully this looks familiar, sounds familiar, something you recognize from geometry, hopefully. But now let's go into something that might be a little bit different, is what is known as a coterminal angle. So I'm going to turn off my picture just in case I'm blocking any of the definitions. Coterminal angles. So they are angles that have the same initial side and same terminal side. So another way to say that is that you start and you stop in the same exact place. Okay. The difference is the number of rotations. They are all going to be 360 degrees apart. Okay. So here in our picture, we have an example of coterminal angles. So we see our initial side here, and we see our terminal side there. It is just how we get to that terminal side that varies. So one option is we start and we just go straight up. That's it. We go boom, straight up, 30 degrees, done. Another option is we go backwards. So we start and we go backwards, negative 330 degrees, and then stop. Okay, so we've got option number 1, I probably should have gone back to red, would be 30 degrees. Option number 2 would be negative 330 degrees. Notice this initial and terminal side look exactly the same. It's just the rotation that we use to get there. The last option, I will switch colors for that one, would be this 390. So what that means is we start on the initial side. I went a full circle and then a little bit extra to make 390 degrees. But each terminal and initial side is the exact same. Where you start and where you stop is the exact same. It is just the rotation to get there is different. Okay, so I'll add that in. It is a different number or direction of rotations. Okay. But they are each 360 degrees apart. The difference between positive 330 and negative 330 is 360 degrees. The difference between 30 and 390 is 360 degrees. The difference between negative 330 and 390 would be 270. There would be 2 of them. But there's always going to be that multiple of 360. So let's see how well we understand that to start with. Turn my picture back on if it will let me. If not, no worries. There we go. Okay, so let's try. Everything is just low for me. There we go. So I have given you 40 degrees. Your job is to tell me each angle that is coterminal to 40 degrees. So that means you would start and you would stop at the same exact place. Okay, so to start with, different ways that you could do this. I'm going to just kind of draw a basic 40 degrees. So there's my initial side. I would rotate up and here would be my 40 degrees. Okay. All I'm going to do is I'm going to start rotating in different ways and see what it gives me. So for example, if I went around 360 and then my 40, that would be 360 plus 40 would give me 400. So 400 degrees is one of my coterminal angles. That's it. I'm just saying, okay, if I went an extra circle around. All right, well, what if instead of going forwards, I started and I went backwards? That would give me basically 360 minus that 40 in the opposite direction, or negative 320. Another way to do this is just continually add and subtract for 360. All of your coterminal angles are going to be 40 degrees, either plus or minus 360, and I'll say n for the number of rotations. So if you went forward one rotation, one full circle, there was our 400 degrees. If I had two rotations or two times around, that would give me 760 degrees. If I did 40 degrees and went backwards one, so a negative rotation, I'm going backwards one, that was how I got my negative 320. Or I could do 40 degrees and go backwards twice. So backwards once, backwards twice. So those two negative rotations, if I add that together, that's going to give me negative 680 degrees. So you can try drawing pictures. You can use your formula where you're thinking all I have to do is add or subtract 360, because that would give them the same starting and the stopping position. Since 360 is a full circle, if I just keep adding a full circle or taking away a full circle, it will get me to the same starting and stopping position. So now let's switch into this talk of radians, and we are going to be using radians a lot more than we will be using degrees. So we need to make sure we can understand them and know how to switch between degrees and radians. Okay. A radian is just a different way to measure an angle. The reason we like to use radians is because, as you see, pi is going to be involved. Now, when you think of circles, think of pi r squared, 2 pi r. Pi is basically came from circles. Okay? Pi is also a number that keeps going on and on and on and on and on and on and on. It is one of those irrational numbers. So pi is actually going to be a little bit more accurate to use since it doesn't end, and it will give us more accuracy there. Okay. 1 radian, so when we say a radian, 1 radian is approximately 57.3 degrees. A radian is just 180 divided by pi. So if you notice here, I put in our starting kind of measurements. 90 degrees is the same as pi over 2. 180 is the same as pi. Okay, so 1 pi is basically half a circle. 2 pi's is a full circle. Okay, so again, 1 pi gives me 180. 2 pi gives me 360. So using that, I want to see how well you can do this before I kind of show you my trick to do this. identify the quadrant where each of these radians will fall. So as a reminder, we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right. So when I look at these, I am actually going to ignore the pi symbol. I look at this and I see each quadrant in degrees was 90. Okay, I went 0 degrees, 90 degrees, another 90 is 180, another 90 is 270, another 90 is 360. Well, what is that basically in radians? Well, I see in radians it's pi over 2, or half 1/2. Notice I'm starting at 0 pi, then I'm at half pi, 1 pi, 3/2 pi, 2 pi. So if you can just remember that each of these quadrants is half pi, I can ignore the pi. This is the same as a half. This is the same as 1. This is the same as 3/2 or 1.5, and then 2. So each quadrant is half pi. Pi over 2, a half. So you might be thinking, well, how the heck is that going to actually help me? So here's what I do. I then look at pi over 4, and I'm thinking of this as not just pi over 4, I'm thinking of this as 1/4. I put that invisible 1 in front, and so that's 1/4. So I start the same thing. I start at 0, and then I ask myself, is 1/4 more or less than a half? It is less than a half, which means I would rotate up, and I would stop here in quadrant 1. So it's just figuring out what is that fraction kind of equivalent. So then I do the same thing here, and I have 5/3. Okay, so I'm going to treat this as 5/3. Plop that in your calculator, and you'll see it's about 1.666 repeating. So then I ask myself, okay, if I start in quadrant 1, 1.6 is bigger than a half. 1.6 is bigger than 1. 1.6 is bigger than 1.5. 1.6 is less than 2. So that means my angle finishes in quadrant 4. A full circle is 2. Half a circle is 1. So 1.6 is less than 2, more than 1.5. So it's stuck here in quadrant 4. So let's try that last one. I really should have switched colors for each of them, but oh well. So then I have 5/6. So again, I'm going to ignore the pi, and I'm going to try this one without converting it to a decimal. Okay. 5/6. If this was equivalent to 1, it would be 6/6. If it was 1/2, it would be 3/6. Okay, so again, 6/6 would give me 1, or 1 pi. 3/6 would give me 1/2, or pi over 2. 5 is between 3 and 6, so that means I'm going to finish here in quadrant 2. 5/6 is more than a half, but less than 1. I know this is very weird when you haven't worked with it before, because it's like, well, what about the pi? Okay, remember, the pi is a symbol that represents a number. So I'm just going to kind of, just like with x, I'm just going to kind of let it sit there, and I'm going to deal with the real numbers that I can see and leave that irrational pi sitting there as kind of a placeholder. Okay. And this is the same with negatives. You would just go backwards. So let's try one real quick. Add it in here, give you a shot at it. Let's do negative 2 pi over 3. where would negative 2 pi over 3 be? Okay, well, just like I did with degrees, I'm going to flip it. So instead of going forward, I'm going to go backwards that 1/2. So this would now be the same as negative 1/2, negative 1, negative 1.5, or 3 over 2, and negative 2. Negative 2/3 is, if I start here, negative 2/3 is more than 1/2. 2/3 is bigger than a half, but less than 1, less than negative 1. So I'm going to finish here in quadrant 3. Hopefully, fingers crossed, knock on wood, hopefully kind of ignoring that pi helps and realizing that each quadrant is a half. So in degrees, it's 90. In radians, it's a half. Okay, so they each have their own equivalent. So the last thing we're going to look at is converting between the two. Okay. Especially as you guys are beginning to work with them, it might be easier to convert things into degrees to help you understand what it is. But we're going to be using radians so much that you don't want to get in that habit of only working with things in degrees. Okay. Hopefully, the more you work with them, you'll start to recognize them and it will become a little bit easier. When you convert, the key is that pi and 180. Okay, so again, we know, if I go back here, that 1 radian is the same as 180 degrees over pi. So that is what I'm going to use to convert. You've probably done a lot of converting in your science classes. When you are converting, you're going to be multiplying by some sort of proportion. Hopefully, again, you've seen this in science, when you're converting, the thing you're trying to get rid of goes in that denominator, because we know that we can cancel things that are on top and bottom. They eliminate. So to go from degrees into radians, since I want to eliminate the degree symbol is on the bottom. So I would take 220, multiply by pi over 180 degrees, because now degree cancels with degree. And I can turn that into 220 pi over 180. And I'm just going to simplify those numbers. You can stick that in the calculator if you want. Right, when I look at this, I see, well, they both have zeros at the end, so those would cancel. 22 is even, 18 is even things I can divide by 2. So that would give me 11 pi over 9. So 220 degrees in radians would be 11 pi over 9. And again, you can do that on the calculator. Let me show you that real quick. The only thing with the calculator is don't put in the pi symbol. Okay. On the right one. Yep. Okay. So I would have 220 times, and I'm just going to say 1 divided by 180. I don't want to put in that pi symbol because it is going to do all the craziness with pi and give me this crazy decimal. We might think, well, it's still giving me a decimal, but remember, I can turn those decimals back into fractions. There's my 11/9. So same thing I got. I just used the calculator to help shortcut for me. Okay. So I go back now to turn into degrees. We do the opposite. So to go from radians to degrees, the goal is to get rid of pi. So when you see a pi symbol, you know you're in radians. When you don't see a pi symbol, that's your clue. You're in degrees. You'll also see a little degree symbol. Okay, so since I'm trying to get rid of radians, that means the pi goes on the bottom and the 180 goes on the top. But it's always pi and 180. It's just deciding which one needs to be on top or bottom. So here I see pi cancels with pi. I know 9 can go into 180 since 18 is divisible. So this would give me 20. So I'm really doing 4 times 20 or 80 degrees. And again, if you're like, wait, I don't want to know how to do that, you can use your calculator, help you out. Let me show you that as well. Again, those pi's got canceled, so I don't need them. So I'd say 4/9 times 180. I could divide it by 1, but I don't need to. But there is that 80 degrees. Okay, so you can always put a 1 in as a placeholder for the pi, because it's 1 pi. So wherever the pi would be, put a little 1 in there, and that would help you out. Hopefully not too bad. Hopefully this cleared up a few things. We will be working with this so much that I promise you each time it's going to get a little bit easier to understand the radians versus the degrees and convert between them. Okay? But for now, don't forget to do your lesson check and have a wonderful rest of your day. See you all next time.